My people, this is a video lesson for Earth's changing climate 2.2. Real quick, I want to point out we do have um, those slides for you with the key concepts. It's always good to review those. This lesson has 4 parts. Part 1, analyze the graphs and answer the warm-up questions. Part 2, you're going to be reading an article, Past Climate Changes on Earth. Very interesting article. You're going to read about times where there were alligators in the Arctic. You're also going to read about times where the entire planet was covered in ice. We're going to have a little discussion in the video, and then in the homework, you're going to make some predictions based on what's in there, the information you have. Then you're going to test those predictions in the sim. So first things first, we're going to click this little log into Amplify button. We want to get to the warm-up page here. And the first thing we're going to do is we're going to analyze these 2 graphs. So this first graph here is our global temperature graph that we've been looking at for a while now, 1880 to 2009. This is a great graph because it gives us a big time scale as opposed to just a little one. Over here on the right, we have a graph that shows the energy that we've been able to measure coming from the sun, and you'll see it. This is actually really normal. The sun has 11-year cycles that it typically goes through, where there's levels of high activity and levels of low activity. And while the trend is somewhat up, but after a while it kind of flattens out, right? And our temperature trend, while it has had some ups and downs, it is obviously going up. And so we're going to answer this question after looking at these graphs here. Does sunlight increase at the same time as temperature does? So let's look at those graphs, and we can kind of see maybe a little bit of a slope, but then it kind of steadies out. Here we see a rise and a dip, and then a big rise, but the average is a steady increase over the last 100 plus years. So we would say no on that one. And then for this question, I will let you answer on your own. What do you think an increase in energy from the sun, or do you think that an increase in energy from the sun could be cause the most recent climate change? And what is your evidence for that? So let's push that hand in button. Pause if you haven't caught up with me. Unpause and we'll move on. So friends, for this, I'm not going to ask you to annotate or anything like that, but I would like you to be a close reader. Read this article through twice. It's a really fascinating article. Like I said earlier, we're going to learn about times. Ooh, look, a dinosaur. We're going to learn about times when things were really, really hot, and we're going to learn about times when, like, here's alligators living in the Arctic. We're also going to learn about a time when things were really, really cold, called the cryogenian period, when the entire Earth was a snow ball. So, students, I would like you to read this article twice. When you are done, you can just exit out and then move on. So here's where we would do our discussion and our annotations. We're going to skip that part. I just want to point out that it is very fascinating that, you know, the climate has changed many times without human action. However, when we're looking at these time scales, you know, we could say, yeah, you know, it's been hotter before, it's been colder before. Most of, if not all of these changes happened a very long time ago. And there were periods that occurred over here where, like the cryogenian period was something like 50 million years, right? That's a time scale that is so hard for us to imagine and wrap our minds around. But it is an important discussion about climate change and where we are now. Let's move on to the homework section, friends. So again, what you're going to do is go through. You get to choose which one you want to test. And you're going to make a prediction that if you decrease whichever one, carbon dioxide or methane, what's going to happen to the temperature. And then what's going to happen with the energy? Is more energy going to enter the exit, or is less energy going to enter the exit, or will they be equal? And then you're going to go to this page and you're actually going to run that simulation. Your procedural instructions are here. And then you'll go back through and kind of re-answer those questions to either reinforce your correct prediction or maybe make adjustments to your prediction if the sim, if the evidence gathered from the sim shows that that was an incorrect prediction. All right, friends, thanks for watching. Don't forget to like, share, comment, subscribe, and I'll see you next time.